Okay, so we now look at simple equation, which leads us to simultaneous equation. What is a simple equation? A simple equation is just an equation with one variable. The difference between expressions and equation, all of we've been doing so far were expressions. Expression has no equal sign. Equation has an equal sign. For an expression, we simplify. For an equation, we solve for the value of the variable. All we were doing here was simplifying. In this case, we have to find the value, the absolute value of x. How do we do that? This equal sign here, we have to take stuff over it and bring stuff over it and so on. As we manipulate the equation, the intention is always to have the variable on one side of the equal sign and the numbers on the other side. So in this case, if we're going to find the value of x, we will have to take over that too. And anything that goes over that equal sign will change its sign. If it's positive on this side, when it goes over, it becomes negative. So that will be a minus 2. And x minus 2, 7 minus 2 is 5. Other persons will do it like this. You have x plus 2 is equal to 7. They will subtract the 2 on both sides. 2 minus 2 equal to 7 minus 2. Right, it's the same thing. When you subtract that 2, it becomes 0. So all you have left on one side is x, and on the other side you have 5. So you'll get the same answer. I think this one is easier. It saves a lot of time in the examination. So we just take stuff over the equal sign. So for this example here, x minus 3 is equal to 8. We take over the 3 because we want x to be by itself on one side of the equal sign. When the 3 goes over, it becomes positive. So we have 8 plus 3, which is 11. You should try to get your x on the left hand side, but there are cases where the x can be on the other side. It's not a big deal. In this case, 3 minus x is equal to 4. Wow, what do? Do you take over the 3? You can. I'll show you this two ways. So let's take over the 3. So you have minus x is equal to 4 minus 3. Minus x. Why didn't the sign change? It did not go over the equal sign. And you must observe not to change your sign willy-nilly. If it's a negative, it's a negative. Don't change it. So this becomes minus x is equal to 1. What do you do next here? Some people multiply both sides by minus 1. You can do whatever. This goes over, I bring over that. So we have minus 1 is equal to positive x. You want your x, your variables to be positive. Or you can say x is equal to minus 1. The other way was to bring over the 4 and take over the x. So we have 3 minus 4. The 4 changes sign because it came over. And the x changes sign because it went over. So we have minus 1 is equal to x. X is equal to minus 1. Another simple way. So what if x is on that side? No problem. Bring over the 3. 5 minus 3 is equal to x. 2 is equal to x, which means x is equal to 2. So it really doesn't matter which side it's on. At the end, you can just flip it around as long as you don't change the sign. Flipping it around doesn't mean that you take anything over. It means if 2 is equal to x, then x is equal to 2. In this case, oh, forgive me, what we were doing here, we were observing how the x is connected to, all these variables are connected to x on this side. If it's connected by addition, when it goes over, it becomes multiplication. If it's connected by subtraction, when it goes over, it becomes addition. This 5 is connected to this x by multiplication. So when it goes over, it becomes division. So we have x equal to 7. In this case, this 7 is connected to y by multiplication. So when the 7 comes over, it becomes division. Equal to y. 3 is equal to y. Y is equal to 3. What about this? Let me see something here quickly. Yeah, I have an example like that. 6 is connected to x by division. When it goes over, it becomes multiplication. 6 times 5 equal to 30. This 4 is connected to this y by division, so when it comes over it becomes multiplication equal to y. Minus 12 is equal to y. Y is equal to minus 12. On this side, we have the x in the denominator. What do? Well, the x, you cannot move the numerator. You just can't take over the 3 and multiply and get 6. That's not correct. You will have to take over the x because we can only move denominators. We cannot move numerators. And for examples, for exercises you can look on this page. So the x comes over and becomes 2 times x is equal to 3, or 2x is equal to 3. And then you take over that 2. So you have 3 divided by 2. X is equal to 3 divided by 2. X is equal to 1.5. Or 1.5. So what about when you have 2 variables on both sides of the equal sign? Well, you group them. Bring over that, take over that. 5x minus 2x is equal to 9 plus 3. Sign change when it goes over. 3x is equal to 12. X is equal to 12 divided by 3, which is equal to 4. You do this one. This one, we have a bracket here. You know how to work out bracket. 3 times 2 is 6x, and 2 times 5 is 10 is equal to 8 on that side. 6x is equal to, take over the 10, 8 plus 10. 6x is equal to 18. This 6 is connected to x by multiplication. So the number goes over first. This number. Addition and subtraction is taken over the equal sign before multiplication or division. You need to remember that. So when that goes over first, and then this 6 comes over after and divide, and you get 3. This is an interesting example here. There's a minus in front of the bracket. We did an example earlier where there was a minus in front of a bracket, and we said we're actually multiplying the bracket by minus 1. Or every sign in the bracket will change. If there's a minus in front of a bracket, every sign in the bracket will change. So this is 2x minus 1 times 4 is minus 4. Minus 1 times x is minus x is equal to 0. The 4 goes over. So we have 2x minus x is equal to positive 4. We don't put 4 plus 0 because the answer will be 4. And this will be x, because 2x minus x is x. So x is equal to 4. So why don't you work this one out? Just like this example, you expand here, you have 6. Let me do this. Pause and do it. 2x plus 6 is equal to x minus 3. This x can come over. So we can group these. How do we do this? Let's take over these numbers and bring over the x. So x comes over. We have minus 2x. Note my sign didn't change. This becomes a minus x when it comes over. We have minus 3 on this side. When this 6 goes over, it becomes a minus 6. When that 6 goes over, it becomes a minus 6. We could have added and get 12 on that side and then bring over the 12. So we have minus 3x is equal to, when you add all of this, you'll get minus 15. X is equal to minus 15 divided by minus 3. Wait, minus 3? But isn't it supposed to change to positive when it goes over? Yes, yeah, but it's connected by multiplication. It's connected by multiplication. So the minus 3 is connected by multiplication. So the minus 3 goes over and becomes division. X is equal to positive 5. There's another way of doing it. Let's do it the other way. Probably a more confusing way. So 6 minus 2. So that's not a minus 6. X minus 3 is equal to the minus x. 3. Good. Expand first. BODMAS minus 2x plus 6 is equal to 3. We can group the 6. So you have minus 2x plus the 6 is equal to x minus 3. And you have minus x plus 12, right? X minus 3. We can take over this x and bring over that 3. So we have 12 plus 3, sign change when it comes over, is equal to x plus 2x, sign change when it goes over. So we have 15 is equal to 3x. 3 comes over, 15 divided by 3 is equal to x. 5 is equal to x. X is equal to 5. Hope that works for you. Finally, for fraction, what do we do when there's a fraction in an equation? This only works in an equation. This will not work when there's an expression. Okay? What we do is we multiply each term by the LCM, and the denominator will go, and then we can work it just like this. Let's see that example. So the LCM here is 35, so each term must be multiplied by 35. 35 times x over 5 minus 35 times 3 over 7 equal to 35 times 1 over 5. Okay? 35, 5 into 35, 7. So we have 7 times x is 7x. 7 into 35, 5. So 5 times 3 is 15. 5 into, that will be 7. So this is 7 times 1 is 7. And you end up with the simple equation. You take over that. You have 7x is equal to 7 plus 15. 7x is equal to 22. X is equal to 22 divided by 7. X is equal to 3 and 1/7. Very simple way. Multiply each term by the LCM and then you cancel. The LCM in this case will be 9. So we have die mosquito. So we have 9 times 4x divided by 7 minus 3x plus 2 divided by 3 equal to 4 divided by 9. So the 9 cancels with the 9. 1, 1. This is just 4x. 3, oh sorry, this 9. We need to multiply that by 9. Sorry about that. The 3 goes into 9 3 times. So 3, this will be minus 3 times everything here. 3x plus 2. And this was supposed to be multiplied by 9. Sorry again. 9 goes with 9 and leave 4. So we have expand there, 4x. You guys will do the other two, except for this one. I'll show you what to do there. This is minus 9x. This is minus 6 equal to 4. Take that over. We have these two will give us minus 5x is equal to 4 plus 6, which is 10. So minus 5x is equal to 10. The x is equal to 10 divided by minus 5. I showed you how you get that minus 5 goes over. So x is equal to plus minus 2. When two fractions are separated by equal sign, rather than finding the LCM and multiplying each term by the LCM, when two fractions and only two fractions are separated by equal sign, we cross multiply. That's when we cross multiply. So 4 will multiply this side and 5 will multiply that side. And then you solve that. What if you had x over, we did this example earlier. See, the bracket separates the fraction. Let's call this a fraction over 1. And you cross multiply. 1 times x is x and 6 times 5 is 30. So when a bracket separates when equal sign separates two brackets, we cross multiply. Sorry, when equal sign separates two fraction, we cross multiply. So now we go to simultaneous equations, and I'll try to solve this as quickly as possible. We're running out of time. we're doing first the elimination method, and I gave some steps here. You can follow them. I'm going to stop this video and do a next one for simultaneous equation.